So this is the third part in my series of building a game with the Intel tools. So in this part we're going to create more complex A-star paths. We're going to move the enemies, and we're going to go ahead and double buffer the playfield drawing. So right now the A-star path only goes left, right, up, and down. Those are the only A-star path directions. But what we want to do is we want to add the 4 diagonals so that it's a more complex and more realistic A-star path. Okay, so here you see I have the number of directions as 4, and these are all my directions, left, up, right, and then down. And just to show you this, when it finally, that's our splash screen, you'll see that all you notice are vertical and horizontal directions. So in order to change it, all I really need to do is add these extra directions, which I have already sort of preloaded, and then just change this to 8. And once I do this, you should see diagonals. Click out of here. Okay, so a much more realistic set of paths. Okay, so the next thing I'm going to do is add a program timer, and then use that program timer to generate the A-star paths and move the enemies towards the player. Okay, so let's walk through these steps. First, I have a set timer. Let's look at our on timer. We call do it, which is the thing that generates all the A-star paths. Then we can validate the rect and update. That just does a redraw. Okay, then let's see. Okay, and here's our first thing we do is I just clear out any kind of the yellow paths that I might have had from the last one. I call the do A-star method. Now this draw path I'm going to go ahead and comment out, so we won't end up getting the yellow paths drawn. And this is just something I did as I was testing through this. So now we're going to go ahead and enable all of this. So here we set the current piece to 1, the enemy piece to 1. We get where they're going to. That's the first A-star path from where they were. We set their position, and we set that piece. Okay, so here again, you won't see the actual yellow paths anymore since I've commented that out. Okay. Okay, so every second, the enemies go closer and closer toward the human player. Okay, so if I drew the playfield normally, you would see a ton of flickering. And I've already done the double buffering in the code, that's why you don't see the flickering. But what happens is when I draw the playfield, and as stuff gets drawn, so it draws the background and then it draws stuff on top of it, and because of that, you see it drawing at different times, which produces what we call flicker. So what we end up doing is we have to draw the memory first, and then we take the memory buffer and we bring it, and then in one fell swoop we draw the memory buffer onto the visual screen. Okay, so here again I've reverted back to my old code that was not double buffered. And as it does a redraw, you'll see how it blinks. And the blink is between drawing parts of the screen. So that's really undesirable. So this is actually, I just commented out my double buffering stuff. So what you do is you create a compatible DC, which is your memory DC. Create a bitmap to draw to. Okay, so basically what you're doing is you're drawing to an in-memory bitmap that you've just created. And then we draw as normal. And finally, once we're done, we'll do a bit blip from the memory buffer onto the screen and get rid of the DC memory. Okay. So now it redraws without the noticeable or perceptible flicker. So the game is developing. In the fourth and final part of it, I should be able to kill the player or score by evading the enemies, and I'll also see if I can add some actual images instead of the blocks. I'm not sure if I can find the pieces though. And that'll be the end of it. And so in the next video, we'll finish up this game.